a circular disk of mass m and radius r. So you are given a circular radius, circular disk of mass m and radius r is rotating clockwise. So it is rotating clockwise with uniform angular velocity omega, right? Okay. Now if it is rotating clockwise, then what is the direction of angular velocity? It is given like this. Basically, if the body is going like this, then you keep, this is the direction of velocity and this is radius, right? So you just keep your hand over here, right hand, and you place your thumb like this, and if the direction of velocity is along this, then you just curl your hand like this, right? So this thumb is given the direction of omega, right? So omega is going like this in downward direction, right? And suppose if the velocity was along this axis, then it will be like this, it will come outwards, right? But in this case it's going inwards, right? Like this, along this axis, right? Axis of rotation basically, right? So about an axis pointing through center normal to the disk, that is this only, at the center of mass. At time t is equal to 0, a torque is applied along the same axis to oppose the rotation of disk. What is the angular displacement measured from t is equal to 0 in clockwise direction, okay, that disk attains before it starts counterclockwise motion, right? So basically currently the disk is rotating in clockwise direction. So we applied a torque to oppose its motion. So of course in linear motion, to stop a motion we applied force, or to give the motion we applied force. Here to increase the omega or decrease the omega we applied torque, right? There's a difference between linear and rotation, right? Okay. So in this we are applying a torque to oppose its motion. So basically if it is moving clockwise, so of course if you apply torque, then there will come a point that its angular velocity becomes 0, and if you apply more torque it will start rotating in different direction, that is in counterclockwise direction. So basically we are asked that disk attains before it starts rotating counterclockwise. So basically we have to check at when the angular velocity becomes equal to 0, correct? Correct or not? Correct, yeah. Hence what is the torque applied? Torque is equal to what? I alpha, right? Of course I should have discussed it before, but I think so that it is the right time to discuss it. So torque is given as I times alpha, right? Alpha is what? Angular acceleration, right? And I is the moment of inertia, right? Okay. So this is torque, right? Hence we can say tau is equal to I into, of course, what is the I in this case? It is mr square by 2 alpha, correct? Correct. Now what is the direction of alpha? Well, if omega is in this direction, so alpha has to be in this direction. Why? Because it is opposing its motion, right? So alpha is creating a motion counterclockwise and omega is creating a motion in clockwise, right? So that is why. Hence we get alpha is equal to negative 2t by mr square. Why negative sign? Because it is opposing the motion, right? So that is why I used a negative sign over here, right? Now we need to find the angular displacement. So what is the formula for angular displacement? We had two formulae, that actually three formulae. Omega is equal to omega naught plus alpha t, theta is equal to omega naught t plus half alpha t square, and omega square is equal to omega naught square plus 2 alpha theta, right? So now which one we have to use? Think and answer. Well, we can use this one. It will be very easy if we use this one, right? Correct. But let's use this and this, so it will be fun, right? If you use this one you can directly get the answer, right? So it won't be that much fun. So let's apply these two, right? Let's calculate time also. So we want omega to be equal to 0, correct? So omega naught minus 2t by mr square multiplied by t is equal to 0. So t is equal to mr square omega naught by 2t, correct? It is simple maths, right? Now theta is equal to omega naught t plus half alpha t square, correct? So omega naught into this quantity mr square by 2t into omega naught minus half into 2t by mr square into square of time, which is equal to m square r to the power 4, m square r to the power 4 omega naught to the power 2 divided by 4t square, correct? Okay, so it will become 4t, right? It will become mr square, and so from this you get theta is equal to mr square omega naught square by 4t, and that's the answer. You solve it. When you solve it, you will see that you are getting this only, right? So this is the angular displacement which the body makes before it comes to rest or before it starts rotating in counterclockwise direction, right? Okay. So this was all about rotation, I guess. And of course, there are some more terms which are related in this, which we can discuss later, right? Not right now. And of course, if you want to find the kinetic energy in this case, what it will be? It will be half I omega square. So let's assume we are finding the kinetic energy initially. So we get half into mr square by 2 into omega naught square. So it is mr square omega naught square by 4, right? Correct?